8 teeth. That is all that was left of them. 8 tiny fragments of calcium and enamel buried under meters of cave sediment in southern Poland, undisturbed for 100,000 years. No grave marker, no ceremony, no one who remembered them. Just 8 teeth and the DNA locked inside them. When scientists extracted that DNA this week, they were not expecting what they found. They were running routine analysis. Another cave, another set of ancient remains, another data point in the long, slow project of mapping human prehistory. But the results that came back from the laboratories in Bologna, Leipzig, and Belfast stopped everyone cold. Because what those 8 teeth contained was not just ancient DNA. It was a family, a real family, a mother and her children, confirmed by science, who lived together in a narrow cave in the mountains of southern Poland 100,000 years before a single word of human history was ever written. And here is what no one is talking about yet. That mother's DNA, the genetic signature of a woman who died in a cave before our species had even reached Europe, is sitting inside your body right now, between 1 and 4% of your genome. She is not entirely gone. She never was. The cave is called Stajnia. Most people will never hear that name in their lifetime. It sits at 1,100 feet above sea level in the Krakow-Czestochowa upland, a limestone plateau in southern Poland, between 2 small villages that appear on almost no tourist maps. The landscape is ancient, forested, quiet in a way that modern places almost never are. The cave entrance is narrow, barely wide enough for a person to enter sideways. From the outside it looks like nothing. A crack in a limestone cliff face. A shadow, something you would walk past without a second glance. But inside, in the rear section of that cave, in just 16 square meters of excavated earth, scientists found something that reached 100,000 years back into the story of what it means to be human. They found the people who came before us. To understand who they were, you have to let go of everything you think you know about Neanderthals. For most of the 20th century, the image was fixed, hunched, brutish, slow. A failed species, a dead end in the story of human evolution. The kind of creature that could never have survived anyway, because it simply was not as good as us. That image was wrong. By 100,000 years ago, when the family in Stajnia Cave was alive, Neanderthals had already been living in Europe and Western Asia for hundreds of thousands of years. They had survived multiple ice ages. They had crossed mountain ranges and open water. They had adapted to climates ranging from Mediterranean warmth to subarctic cold. They made tools, not crude rocks, but carefully engineered implements that required planning, skill, and the ability to teach others. They hafted spear points with adhesive they manufactured themselves. They created pigments. They used feathers for decoration. They buried their dead. That detail matters more than almost any other, because burying your dead is not instinct. It is not survival behavior. It is something else entirely, a recognition that the person who died mattered, that their body should not simply be left, that something was owed to them even after death. Neanderthals did that. The family in Stajnia Cave did that. And when scientists extracted the DNA from those 8 teeth this week, what emerged was not the profile of a primitive creature stumbling toward extinction. It was the profile of a mother and her children. The DNA analysis was meticulous. Teeth are the best source of ancient genetic material. The enamel acts as a natural vault, protecting the DNA inside from the moisture, bacteria, and chemical processes that destroy organic material over millennia. 100,000 years is an almost unimaginable span of time. The fact that readable DNA survived at all is a small miracle of preservation. Scientists extracted mitochondrial DNA, the genetic material that exists outside the cell nucleus, passed exclusively through the maternal line. Mother to daughter, mother to son, an unbroken thread running backward through time from child to mother to grandmother to great-grandmother, generation after generation, for 100,000 years. When they sequenced it, 3 of the 8 teeth came back with identical mitochondrial profiles. An adult, 2 juveniles, the same maternal line, the same mother. 100,000 years later, confirmed. A mother and her children, sheltering together in a cave in southern Poland, in a world so ancient it barely resembles our own. And then the scientists looked further. They compared the Stajnia DNA against every other Neanderthal genetic profile in the global database. What they found rewrote the map. The mitochondrial DNA of the Stajnia family, This one mother and her children in one cave in Poland matched a lineage previously identified in Neanderthals from the Iberian Peninsula, from southeastern France, and from the northern Caucasus. One family, connected by blood to individuals thousands of miles away. A network stretching from Poland to Spain to the edge of Asia. Invisible, ancient, vast. We had no idea it existed. Until this week. Think about what that means for a moment. 100,000 years ago, there were no roads, no ships, no written language, no maps, no nations, no borders, nothing that we would recognize as civilization. And yet, across the entire breadth of Europe, from the Atlantic coast of Spain to the mountains between Europe and Asia, a single maternal lineage was present. Neanderthal communities were not isolated. They were not scattered pockets of desperate survivors clinging to existence in separate valleys. They were connected. They were moving. They were maintaining genetic relationships across distances that would have taken months to travel on foot through dense forest and across mountain passes. The mother in Stajnia Cave was part of something far larger than that narrow cave in Poland suggested. She was part of a continent-wide network of families. And she and her children had no idea. Every morning that family woke up in that cave, they faced a world that was trying to kill them. The climate was unstable, warmer periods giving way to sudden cold snaps that could devastate the plant and animal populations they depended on for survival. Predators that no longer exist competed with them for the same prey. Disease moved through small populations with devastating efficiency. Childbirth was dangerous. Injuries that would be trivial today were often fatal. And yet they survived. They hunted in the forests below the cave. The bones found in the cave deposit include the remains of woolly rhinoceros, cave bear, and reindeer, animals that required genuine skill and coordination to hunt. Not scavenging, not luck. Organized, planned, cooperative hunting. They came home in the evening. The children slept pressed against the mother's warmth. The fire, if there was one, would have been visible from the entrance, a small point of orange light in the darkness of the limestone upland. Outside, forests, mountains, night. Inside, a family, 100,000 years ago. And then, they disappeared. Not suddenly, not in a single catastrophic event that we can point to. Slowly, over thousands of years. The genetic line of the Stajnia mother, the line that connected Poland to Spain to the Caucasus, was replaced by a different Neanderthal population. A different lineage moving into the same territories. Then that population too began to fade. Because roughly 45,000 years ago, something new arrived in Europe. Us. Homo sapiens had been in Africa for 200,000 years. They had already spread through the Middle East and into Asia. And then, in a movement whose full complexity we are only beginning to understand, they entered Europe. What happened next is the most debated question in the entire study of human prehistory. Did we kill them? There is evidence of conflict, Neanderthal bones with cut marks that may indicate violence. Did disease destroy them? Modern humans arriving from Africa would have carried pathogens to which Neanderthals had no immunity. Did climate change finish what other pressures had started? The period of Neanderthal extinction coincides with a series of dramatic cold events in Europe. Or did they simply, slowly, over generations, become us? The DNA says yes. The DNA says all of the above, and that last one too. Because every person of non-African ancestry alive on Earth today carries between 1 and 4% Neanderthal DNA in their genome. It is not a rounding error. It is not contamination in the sequencing process. It is the genetic record of real encounters between real people, Neanderthals and Homo sapiens, meeting, living together, having children. The mother in Stajnia Cave, her children pressing close to her in the dark. They did not simply vanish. They merged into us. They are still here, fragmented, diluted across 10,000 generations, but present. In you. Right now. 8 teeth in a cave in southern Poland. Published this week in a journal most people will never read, by scientists whose names will never trend on any platform, in a story that almost no mainstream news outlet has covered yet. And yet what those 8 teeth contain is one of the most profound things science has confirmed in years. That the line between us and them was never as clear as we thought. That the creatures we dismissed as brutish and primitive were mothers raising children in mountain caves, maintaining family connections across an entire continent, surviving in a world that made survival genuinely difficult every single day. That when we arrived, when our ancestors came north into Europe 45,000 years ago, we did not simply replace them. We became them, and they became us. The mother in that cave is not a footnote in human prehistory. She is part of the story of every human being alive today. Her DNA traveled forward through 100,000 years of history, through ice ages and migrations, and the rise and fall of every civilization ever built, to reach the present moment. To reach you. She is not entirely gone. She never was. And this week, for the first time in 100,000 years, someone finally found her.